let's talk about testing web apps in JavaScript. Here's the part where I tell you I am definitely going to post the slides on my site tonight. Have you heard that before? Has it worked? Yeah, that's one of my pet peeves is people who say I'm going to post the slides on my site tonight, which is why you can go to robrich.org right now. Let's head there. Click on presentations here at the top, and here is scaling the testing pyramid in TypeScript. The slides are online right now. Achievement unlocked. Woo! The code that we're going to look at is also online up on GitHub, and the link is that code link right there. So we'll get to see the content that is online right now as well. So while we're here on robrich.org, let's click on About Me and we'll see some of the things that I've done recently. I've gotten some awards from Docker and Microsoft and Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp, or if you'd like a Give Camp here in Bangalore or wherever you traveled from, find me here at the event. Hit me up on Twitter, email, Mastodon, LinkedIn. Here's all my links right there. And let's get a Give Camp in your neighborhood too. Some of the other things that I've done, I run a user group in Provo and one in Phoenix, and I got to work on a few books, which was really fun. But one of the things I'm particularly proud of is I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my claim to fame, my trophy, my coveted .NET Rocks mug. And if you'd like a .NET Rocks, no, I'm just kidding. They actually don't give away .NET Rocks mugs anymore. They give away music to code by. Okay, so let's take a look at this. We want to write some tests inside of JavaScript. Now, we can talk about time to first it. Like how quickly can we get a JavaScript test written? In this case, I'm going to write it in TypeScript instead. So I'll change the TS to a JS, or JS to a TS, and now we've got TypeScript tests. Okay, so it should pass. And I'm going to go hit my cheat sheet because I think I screwed that up. Yep. It should pass. Cool. So now we can say assert true. Let's pull in assert. Import assert from assert. And now we have a test. We can come in here and we can say npm test. And we have a passing test. Wow. My machine is definitely under load being on battery. This is interesting. Well, imagine that the test passed. So what did we do here as we built this? Well, the cool part here is we just have time to first it. We can give it a description, should, do stuff, and then we can describe the code that will actually do it. Now, we can take a look at different frameworks, but I'm going to import expect. So expect from Chai, and now I can say expect true to be true, and I didn't do that quite right. Oh, expect, I don't need to import. It's already just there because I'm using just, not Chai. Cool. So now we can start to make it a little bit more descriptive. The problem that I have with assert is this. I was running this test where I had expected an actual, and so const expected equals 7, const actual equals 5, and I was debugging my test, and I'm like, I expected to get 7, and I debugged it, and I got 7. So why does it think I ought to get 5? Well, actually, I had expected and actual backwards, and so that's what I should have done. And so separating that out a little bit, one of the reasons that I like this expect syntax is that it makes it really clear, here's the actual and here's the expected. Excellent. Now, next let's start talking about the arrange, act, assert pattern. Arrange, act, assert. So here's my assertion, it'll be there. Here's my implementation, it'll be there. Here's my expected, it'll be there. And so this arrange, act, assert pattern is really nice. We set up the condition that we need, and then we do the thing to make that condition happen, and then we validate that we did what we expected. So that's really cool. Did my test ever run? Woohoo! I got a passing test. So we've got this add library here, and we need to test this add library. We take in 2 numbers, and we've annotated these with TypeScript, and we need to return the result. So let's go build a test for this. New file, add.ts. So it should add 2 plus 2. Oh. WSL is being grumpy. Stopped. Oh, and it blew away my Docker. So all of my demos will fail, but this will be entertaining anyway. I think I can still serve the UI. It'll just do bad things. Okay. It should add 2 plus 2. So let's create our implementation. And now I'm going to do my arrange, act, assert pattern. So what do I want to do? Well, I want to test drive this code a little bit. So I want to expect actual to be expected. Cool. So what do I need to do? Const actual equals add x and y. Okay, that means I need to import add. So let's import add from source add. Excellent. Oh, did I export it as a name thing? I did. So let's do this add here. There we go. Fixing the ESLint fails. Okay, so now that we've kind of test driven our test, now we know what we need to do to set up to make this happen. Well, I need a const x equals 2, const y equals 2, and const expected equals 4. Now this test will pass, but what if my implementation was broken? What if instead of adding, I multiplied? Well, 2 times 2 also equals 4. So I think this test setup is probably not great. Let's not add 2 plus 2. Let's add 2 plus 3. Because I know that 2 plus 3 will equal 5, but 2 times 3 will not. Now I'm better validating my stuff. So now we have our arrange, act, assert pattern, and we can come in here and run npm test. And wow, battery is quite the thing. Okay, so imagine that passed. Now we can also group our tests into groups. So let's say describe, add. And now I'll just create a function there. And now all of these tests inside this describe block are kind of grouped together, which we would see in the test results, as you can clearly see in the test that didn't run. So we could also create another test. JavaScript being the thing that it is, we can say, well, we can also add A and B, and so that should turn into A, B, and TypeScript is getting mad because I just passed in characters instead of numbers, but we could build that test and that would work just as well. Cool. So that's kind of how we get started with testing. We can see that we arrange act assert to be able to get that set up. So now, how do we look at testing in web apps? Well, we did that testing demo. That was really cool. So why do we test? Well, we test to be able to validate the functionality that we have in our app. But we can also test to document the features of our app. We can also test to reduce risk. Now, this is really cool because if we're doing risk mitigation, perhaps it's cheaper to write a test than to fix production during an outage. So we'll just write a test and that will be able to validate it there. So there's lots of different reasons that we might choose to write tests. Now we also have lots of different types of tests. End-to-end tests, unit tests, integration tests, and we can kind of put these on a continuum where we have the most expensive, the slowest tests at the top. So we'll probably write fewer of those. And the fastest tests at the bottom, so we'll probably write more of those. We want more unit tests because they will fail fast. We can validate our system a lot quicker. So we end up with a pyramid kind of like this. Now this is cool. We have a pyramid where we have lots of unit tests, a medium amount of integration tests, and really few end-to-end tests. Now this is great, but we probably do something like this. Oops. We have a few unit tests, a medium amount of end-to-end tests, and a whole lot of just clicking every time. This is not how we want to do it. We don't want to get paid to click the button every time. We want the machine to click the button. We want our people to be able to do exploratory testing, validating systems work in unusual ways, put interesting inputs here. That's really what we want our tests to do. So we really want this type of testing pyramid. A lot of unit tests, medium amount of integration tests, and a few end-to-end tests to just validate the key scenarios. Those will be the slowest ones. So we're building progressive web apps, PWAs, or single-page applications, SPAs, inside of a browser. How is this testing going to be different applied to our web apps? Well, we have a lot of different types of tests. We have integration tests. We have browser tests. We probably also want component tests. We probably want to test our APIs, validate that they work as expected. We might want to test that this works in that browser. There's lots of different types of tests that we might want to look at here. And this talk actually grew out of this slide. This was a slide in a different talk where they asked me, well, can you do a talk demoing all of these? Welcome to this talk. We're going to build some in all of these. What tools might we use if we're just unit testing an application? Well, if we're just unit testing an application, we might use Mocha with Chai, or we might use Jest, or you may still be using Jasmine. Now the cool part is that Mocha with Chai and Jest are pretty much the same. Jest and Jasmine are almost identical. If you want to run those unit tests in a particular browser, you might choose Karma, or Cypress now has a really elegant way to test these as well. Now this isn't running user interactions, clicking through things. Rather, it's just running our unit tests in a particular browser. So does this browser support this way of calling the thing? Now that validates that, for example, when we're running in Safari and it doesn't have that API, that we're still doing okay there. Next, we might want to do component tests. Now, when we're doing component tests, we need to mount our component. Maybe we need to mock child components. Maybe we want to test our child component, render our child components. So we'll use test utils. And there's a test utils variant for each SPA framework, Angular, React, and Vue, also Svelte. So we'll use the test utils specific to that framework, and we'll be able to do some really elegant things there. If we're doing API tests, the interesting thing here is that we can just hit that API. We don't need a browser in here at all. We just want to fire requests at it and validate that the responses are what we expect. So if we're using Axios in our client-side code, we could use Axios to validate our API as well. And then end-to-end tests. We have lots of choices here. Selenium might be the product that you're familiar with. We'll do Cypress here today, but Test Cafe and Playwright and others are other great end-to-end tests. With end-to-end tests, we're actually clicking buttons as if we're users and doing the interactions through our website. That's really cool. As you grab these slides from robrich.org, you can click on each of these blue links to learn more about that particular product. And the cool thing then is you can validate that that system works as expected, get a feel for that tool, and if it helps you, then that can be great. So which of these tools might we use when we're testing our website? Well, all of them, or many of them. It depends on what we're trying to test. And so in this talk, we'll take a look at component tests, and unit tests, and integration tests, and API tests, and end-to-end tests. So we'll get to experience all of these tools and get to feel for how they work. A note on Mocha with Chai versus Jest or Jasmine. On the right is Jest and Jasmine. On the left is Mocha with Chai. .2.equal versus .2b. That's the only difference. If you're happy with Mocha with Chai, or you're happy with Jest and Jasmine, I completely agree that is the correct tool for you. You don't need to switch tools just because it's not doing the thing. Cool. So now TypeScript is really cool, and part of why we've layered TypeScript into this talk is that TypeScript has some weird pieces that we might want to explore. TypeScript is great for being able to validate our syntax and catch typos. It's not going to test our application. It's not going to validate our business logic. But there are some intricacies with TypeScript, especially as we get to mocking. So we'll get to experience TypeScript here. Mocking. Now, when we do mocking, we're going to replace an expensive resource with one that we have more control over. If we're going to go call that API, we don't actually want to charge the credit card. We don't want to actually send the email. So let's fake that API. And now let's return things like, well, an error response or a success response. And now we can validate that our application behaves correctly if we get these error conditions or these unusual expectations. That's pretty cool. Now, mocks, stubs, fakes, yeah, technically they are all different. And as we start peeling the onion, we can definitely have that conversation. Let's do that over beverages later. But for now, I'm just going to group them all into the concept of mocks. Cool. So we've got all of these tools. Tools for unit testing, tools for running these unit tests in a particular browser, not just JS DOM inside a node. Tools for running component tests. Tools for running API tests, and tools for end-to-end tests. Cool. So now let's take a look at the application that we're building, and because I couldn't get Docker Desktop to start, and it deleted the things, which means starting it back up will take a web connection. Let's take a look at this application, which definitely won't work. Oh, maybe it will. Cool. So I wanted to pick an application that didn't have super complex business logic, but which had enough complexity that we could kind of get a feel for it. So I chose this game. And so now we can do stuff where, you know, we can run and then we win. And so once we've won, we can't click on any blank squares. We can't change the squares. So there's enough business logic here. We also have this component that will ask us yes or no if we're in the middle of a game and allow us to do some things there. So cool, we have an application that has enough complexity that building each of these kinds of tests will be helpful, but not so much that it'll get too much. And so here's our leaderboard that calls into our API that stores its data in Redis, but Redis isn't running, and so right now our leaderboard is blank. So let's pop open this application inside of VS Code and take a look at the various types of tests. Now first on our front end, here is our view app. Main.ts starts up our view app and just says, hey, go mount app.view. So app.view will get us started. Now we could definitely build this in React or Angular or Svelte or Ember or Handlebars or AngularJS or jQuery. Have I gotten back into the dinosaurs yet? I chose to do it in Vue because, well, I kind of like Vue. So we're going to build up our thing. We have the X and the O that will show if it's correct, show whose turn it is, and show if it's the winner. We have an array of squares. We have our new game component and our leaderboard component. And then here we have our game loop that will just run. So every time a tile is clicked, we'll run that game loop. And if it's not over, then we'll flip to the next turn. Here's our game loop where we go check to see if it won, check to see if it's stalemated. If it won, then we'll go update our winner, update our score with our API. And if it's a stalemate, we'll also update our score as a tie. The next turn just flips the player, and then the new game will reset all of the squares. Cool, so that's our main component. Let's pop into the leaderboard component because that one's kind of interesting. The leaderboard component will show the scores of each player. So here we're going to pass in an array of scores, and then we'll just render those scores. Now the cool part is in this component, we're not actually getting the data. We're not doing any computation. We're just rendering the things. And that will make it really easy for us to test this component. We're actually doing the fetching the data out here. Arguably this component is too big, but yeah, we can argue about that. But the cool part is that this component, this leaderboard component, is really just rendering. So as we mount it, we can validate that it renders correctly. So now here, as we get to our thing, we start off by getting the scores. And getting the scores then came in from here, from the scores class. So this scores class client side is just a repository around our data access. So we'll go call into /API/score to be able to get the current scores. As we update our scores, we'll pass in the winner to that update, and we also have a clear scores. So now flipping from our client side to our server side, we'll go hit the scores route. And so here's our get route and our get method. Now our get method will go find that Redis client from this mechanism right here. No, it'll go get our Redis client from where we set it up here in app.ts. So we just said go create a database client, and it goes and initializes it with the correct connection string. And so now that we've set that in place, let's go get that Redis client. We'll pass it into get scores. And then if Redis is blank, we want to go use our default scores instead. So the score here takes in that Redis client and does some stuff. Yeah, I probably should have created that database client as a singleton, exposed it somewhere else where I didn't need to pass it around inside my route. But this is kind of a cool scenario. Testing this will be fun because, well, it's a little weird. Now, the one thing that I didn't do was just set this inside my route because I wanted to be able to export it as a separate function so that I can unit test this function outside of the router. Cool. So it calls into the data store to go update Redis or to get the data out of Redis. And so there's our data repository inside the backend. So now flipping back to the front end, here's our app.view, and we're going to check wins and check stalemates. Now that check win function is actually pretty cool. Where did it go? Check win. Services, check win. Cool. So here's all of our win conditions, and we just hard coded it because, there's only 9, so having that list is good. And so when we check win, we'll go find all of the conditions where all of those squares are the player that we're looking for. Cool. So we'll pass in our squares, pass in the player, and we'll return if that is a winning condition. Cool. So let's create a unit test on this function. Now the cool part is this is just calculation. So this unit test then, we will build up the computation that we need to be able to validate this. Now here's that arrange act assert pattern. Arrange. Now yes, this is one big array, so I could have chosen to format it like this. That is completely valid code. ESLint may actually get mad at me because I formatted it this way, but I chose to format it this way because it describes how my application is working. You can kind of see the game board here and really intuitively understand what's going to happen. Yeah, I have an X win right here. So I expect that 2, 4, and 6, it's a zero-based array, will be the win, and so I can run that unit test. Cool. So let's create an O condition and validate that that works. Let's create a tie condition where there is no winner and validate that that works. Now I noticed that the act and assert were pretty much the same in all of these tests. So rather than duplicate that, I did move towards being a little bit more dry here. And so here's the run test where it takes in those things, turns the squares into, or the players into squares, so that I can go run that check win function, get my actual, and then expect my actual to equal expected. Cool. So now I've been able to validate that validate this function. We could create similar unit tests for checking stalemate, for checking other details, but that's really cool. We did a unit test here with Jest. Next up, let's take a look at component tests. Now we have this leaderboard component, and the cool thing about this leaderboard component is for the most part it's just rendering stuff. So what might we test here? Well, I want to test that if I pass in the right data, it's going to render correctly. So I might choose to pass in lots of scores. I might pass in a blank score list. So let's flip over to the leaderboard test. Now here we're going to pull in test utils. In my case, I'm using, pardon me, I'm using view. So we have the view test utils. I pull in my component, and I'm pulling in the interface for TypeScript for the scores. Okay, so let's set up a scenario where I have no scores. I'm going to mount that component, passing in the props that I need for that component, and then let's go grab the text for that component. Now the interesting thing is that if I don't have any scores, I won't render this whole section. So all it'll say is leaderboard and clear scores. So back in our test, we can just say the text for that is leaderboard clear scores. Cool. I validated that I didn't render any scores. Okay, so let's take a look at another scenario. I'm going to set X to 3, O to 2, tie to 1. Now I did want those to be different numbers so that as I go check to make sure that it renders correctly, I know that I'm getting the right rendering. So let me check that tie is 1. I'm mounting my component, passing in my props, and now I'll go grab the text. But instead of just validating the entire text, I want to say .to contain this piece. So let me find a substring of that in this string. Cool. So we're able to validate that this component works as expected, renders as expected. Now let's take a look at the board tile test. Now our board tile, we didn't look at that component yet. Here's the board tile. We're just rendering the thing and we're passing in some font awesome icon based on who that player is. So I'll take in a prop that is that player. I'll do some rendering of that function and validate that it works as expected. But I also want to catch the click. Now I want to make sure that you can click on it if it hasn't been played, but you can't click on it if it has been played or if the game is over. So let's create some unit tests for that. Here in the component test board tile. Now the first test that I want to check is if you click it and it hasn't been played and the game isn't over, that works. Okay, so let me go mount that. Let me go find the square and trigger the click. Now I want to validate that it got clicked once, but there is a bug here in the test utils that it doesn't actually correctly validate the this part where I say, no, not there. This part. Oh, where's the thing? There's a thing that you can pass to your component that won't propagate the, oh, there it is, dot stop. It actually does, view test utils has a bug that it's not correctly handling stop. So I'm going to say, if it's not clicked and it's not game over, then emit this click event. So here in my test, it actually rendered twice because of that bug. Okay. Let me now make the game over true. I'll mount my component and then I'll click the button and now it didn't render the component because it only fired that event once. Now once they fix that bug, I'll have to go through and reduce all my numbers by 1. But that's a really cool component test talking about the functionality. Next, let's take a look at the server side where we're looking at this this score get method. Now back here in the score get method, we saw that we need to go get a Redis out of Express. We call get scores, passing in that Redis, and if it returns blank, then we want to return the default scores. So here we get to play with mocking. This will be cool. Okay, so I want to arrange this such that the score is this, or this is what the default score is, but Redis is blank. Now, in passing in the content to this method, we pass in, we pass in a request and a response. So we're not actually calling the function, we're kind of doing some stuff, and it's calling res.json. So our first task then is to mock up some of these things. So that was the one I was on. Okay. So I want to first mock up the getScores method. Now I'm choosing to import getScores right. Oh, the getScores method is down here. Where's the API? I'm looking at the wrong one. I flipped. There we go. Test, unit test, score. That's the one I'm looking for. Cool. So let's start by setting up the getScores method. Now here, the getScores method, I chose to import the getScores method as here from score data. I imported star as score data because I wanted to be able to replace that thing that my test called. If I had just said import getScores, then it would only replace my local copy, not the one from the other thing. So I definitely want to import star as score data. I'll also import that way for the default. And I want to make this stub before I actually use it. So let's take a look at that setup get scores method. Now I chose to move it to a separate method so that the setting up of the mock doesn't clutter my test. This test now is really legible. Here's that get scores method. I want to create that mock function on the score data object. I want to replace get scores, and I want it to return this Redis scores that I passed in. Cool. And it actually, this mock library will return a sign-on stub, which is pretty cool. So back here in our get setup scores, we're going to pass in what our Redis should return, in this case undefined. Let's do the same thing for the default scores. We'll just create this mock here and replace default. Now why is this default? Because here in this, not there, here I said export default. So it was named default, so I'm going to mock default. Cool. Back in our unit test. Now we need to mock our request and response because we're just going to call the get method and pass in this request and this response. We're not getting a const actual because it's calling methods inside of that. So let's set up some mocks here for express. Now this is really cool. I want to create a mock request, and the only things that I care about on that request are an app property that has a get method that will return something that we can pretend is Redis. We don't need it to actually be Redis. We just need it to pretend to be Redis enough that we can do this. Okay, that's fine. So now how do we do this? Well, we'll just go create a mock that is of type Redis client, and we're not implementing any details on that, so it'll just do what Redis does. Cool. So we have this get method that will return that fake Redis, and we're passing it in as a partial of request. Now partial is this really cool TypeScript concept where we don't implement all the properties, just those portions that we need, and that's perfect for creating this mock. We'll create a mock response that has a JSON method where we take in that body, and we'll just call this callback that we passed in to be able to grab the data that they set just so that we can use it elsewhere in our test. And we'll return this in case they want to chain the thing. res.json.setStatus or res.json.end or something like that. So now that we've got our request and our response here, now let's go call that. And so it's going to go call our regular method here. Now it's passing in the fake Redis here. It'll pass that off to get scores. We've mocked out our get score with the fake get score that we set up here. And then when we finish, that isn't it. When we finish getting that result, it will be blank, so we'll call default score, and then we'll call res.json back in our test. Then now we called that JSON, where I'll just set it to the scores property. Now let's expect scores to be the default. We were able to validate that API works as expected by mocking out Express and mocking out Redis, both expensive resources that we don't want to futz with. We could do similar tests for if Redis was set, and we could do similar tests for post and delete. And so, we can definitely wander through those in interesting ways. What did I change here? There we go. So that's a unit test where we start to do mocking. Now let's do an integration test. Now here's an integration test where we want to be able to validate that this API scores method works as expected. Now here is a from here down test. We're still in our back end. So let's just call this get method passing in /API/score into our app. So how do we spin up our app? Well, let's just go call app init. Okay, so yeah, I did a little bit of weirdness here as I set up my app because I wanted that to be a function that I can call so that I can spin this thing up when I need to and spin it down at the end of the test. Have you ever run your tests and they all pass and then it hangs? Probably because you left the connection to the data store open. So here I'm creating a data store connection and I want my test to be able to do that, but I also want to then, after all the tests, go find that Redis client and quit the Redis client so I'm not leaving that connection open so that my test will succeed correctly on the way out. Perfect. So let's go call get API score. Now we don't know what Redis has in it, so we can't validate that, for example, x is 2 and y is 3, but we know that it's set to something. So let's just validate that it's truthy, that we got a result back. And then let's return that. We can do a similar thing with post, where we have a particular player that won, and we know that when we do that post, we will return the new scores that were updated. So you'll notice that these are not it functions, they're just functions that I call from this third test that just calls get scores and post scores and validates that the initial scores and the updated scores are different in x by 1 and different in y, o and tie by 0. Cool. So I was able to do an integration test with my API and validate that I could behave correctly calling get and post, even if I didn't know what data was in Redis yet. Cool. Now, let's take that to the next level of doing an API test from our front end. So here in our front end, let's take a look at the API test, and you'll see that it looks really similar. Now, previously we had open box testing where we could just instantiate the thing and call it and run it. Here we need to make some assumptions like that our app is running already. But we'll go grab an API base URL from environment variables just in case, call get, call post, validate that they're the same. But here, because we're doing closed box testing, we don't quite know how it works. We're just calling axios.get, assuming that that server is doing what we need to do. Cool. Next up, we want to do end-to-end tests, and I'll just quickly run through an end-to-end test where we have this end-to-end test, where we'll just hit that API and validate that this is as expected. Now I want to validate that my H1 says tic-tac-toe, but then let me go click on stuff. Click X for 0, Y for O for 1, X for 2, 5, 4, 3, 6. That should yield a win for X, and let's go validate that that win works as expected for X. Cool. A similar validation test in Cypress for O winning, and a similar validation test for a tie. And now we're actually clicking buttons inside of a browser. Cool. So now how do we launch these tests? Well, we want to launch our unit tests first. We want to fail fast. So let's look at the package.json for our backend. Here's the package.json for our backend, and we're just going to run jest. Yeah, our integration test was just part of that whole bundle. But let's launch that first and validate that that works. And then when we get into our front end, then we'll get a little bit fancier with our package.json. Okay, so we want to run our unit tests first. Those will run the fastest, and we probably have the most of them. So let's run our test unit. Where is it? Test unit. So we'll just run view CLI service, which actually runs jest under the hood. We'll pass in a specific jest.config so that we're now testing the unit test for the front end. So that jest config basically just says run this unit folder. Cool. Then we'll run our API test. Now here we're passing in a different jest config to be able to run those integration tests against that foreign API. We're just validating that that API works. Then we'll run our Cypress tests, test end-to-end, where we're going to go set some legacy providers because Webpack 4 and Node 19, and then we'll run our tests in headless mode. Okay, so as part of both the API tests and the end-to-end tests, we assume that our backend is running. So let's launch our backend. Here's Start API. So we'll just go reach into that up one folder into the API folder and start it. Cool. Now that backend API is launched, and now we can do some interesting things. Here's Start Server and Test, which I'll actually call Start Server. Wait for port 3000 to be available, and then run our API and end-to-end tests. And then npm test runs our unit tests, and then our integration tests, and fires up our end-to-end tests as well, killing the server once it's done. Cool. So we just did unit tests, we did component tests, we did integration tests, we did mocking, we did end-to-end tests, and now let's launch all of that from a DevOps pipeline. So up here at the top, here's our GitHub Actions DevOps pipeline. It will start Redis nicely, which is really cool. And then we'll check out the code, set up Node 19. Then in our API, we will install, npm install, npm run build, npm run test. So that'll run all of our backend unit and integration tests. Then we'll go into our app directory, npm install with legacy peer deps until they merge this this PR. Then build and test, which will run our unit tests, then our integration tests, then our end-to-end tests, and we're going to pass in the environment variables that we need to be able to set up Redis correctly. Cool. Now, I do want to harvest this test report so that we'll get these results really nicely, and I've kicked off Redis at the same time. So let's fire up our API, presuming internet access. Yes. And I'm bummed I didn't get to show you these things running locally, but let's run them remotely instead. Let's kick off this workflow. Here's our new tests. Starting the job. Okay, so let's go download our containers that we need for this job. We'll get Redis started as our data store. Oh, we're waiting for a job runner. I've actually noticed that sometimes it does that and gets stuck there, so I'm going to launch it again just in case. There we go. So we're setting up Node, and then we'll, I'm surprised this build runner is slow. No, go, 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 go. Okay, so we've set up Node. Let's kick off our tests, our build and test. So we'll build our backend, our npm install our backend. Then we'll build our backend. Then we'll test our backend. Looks like we've got some green tests from our backend. Excellent. Now let's flip to our front end. Ooh, all 5 of our backend tests pass. Excellent. Flip to our front end. We'll npm install our front end. And then we'll npm build our front end. And then we'll npm test our front end. And I'm going to skip ahead to the end because it's really cool. So here's our test results. And because we pulled in that test report at the end, we now have this really cool screen that is able to show us all of the tests, the time for each test, the fact that each test passed, and the console output for each of those as well, which is really cool. One of the things that's particularly awesome as well, using Cypress, is when it runs these tests, it actually also captures a video of that test run. So we can say, have you ever run a test and it doesn't work and you're like, but I don't know why it doesn't work? This video actually shows us the steps that we went through to run all of these integration tests in this thing. So here's Cypress doing all the moves. Oh, that's why the test didn't pass, because it didn't click on that button correctly. It's so much fun that it gets to pull in these tests. Cool, so let's go back to our other build. I bet it's finished by now. Nope. Almost. But that was really cool. We got to see lots of different types of tests in each of the scenarios with each of these different tools, and that code is available right now up on GitHub. So let's take a step back and talk about what we did. We did a unit test, we did an integration test, we mocked our dependencies, we tested our components. We could take this farther. We could do performance tests. We could do static analysis tests. We could do UI tests. We could validate that it renders correctly. We could validate accessibility and contrast. The WCAG 2.1 test is really cool at being able to validate contrast. There's lots of other types of testing we definitely could do with this app. And arguably for a to-do app, we've already gone a little bit too far. Now taking a look at our testing triangle. As we take a look at the testing triangle, we can see that for unit tests, we're using fake dependencies. We're mocking those dependencies. For integration tests and end-to-end tests, we're going to use real dependencies. In the most case, we don't want to charge credit cards, but we probably do want a real database. Now, a test database, so that we're not modifying production data, but we really want a database to be able to validate that. So, starting from our unit tests, we use jest. Then in our mocks, we use TS mock imports, TS auto mock to be able to mock dependencies and parameters respectively. We use supertest and Axios to be able to call into APIs. And finally, for our end-to-end tests, we use Cypress to be able to do that rich interaction, clicking through things. Now, we did a lot to be able to validate our components work as expected. This is one of the purposes of our test, but this isn't the only purpose of our test. We specifically coded for legibility. Remember when we were documenting how X would win and we built that array that looked exactly like a game board? We coded our test to be simpler, more legible, to be able to document the intent of our code so that we could now use that perhaps as documentation to be able to see how our site works as expected. And then the third thing is risk mitigation. Is it cheaper to just go fix production than to write these tests that will run and to build, and then don't write tests? But if it's more risky to leave that suite untested, then let's write a test for that. So we'll probably start by testing all the happy paths, the critical business functions. Let's go, for example, load our home page, switch to our product catalog, add a thing into our shopping cart, get to the checkout screen, fill in our details. Now, we're not actually going to charge a credit card. We're not going to push purchase. But we're going to get right up to it. And we'll run that test as an end-to-end test a lot. That's the critical business function in our application, to be able to validate that users can make purchases. Wouldn't it be nice to know that your purchase path is broken before a customer calls? That's where risk mitigation is really important. Is it important to validate that the marketing pages pull up? Not so much. Let's not write a test there. Testing is about risk mitigation. So some best practices that we saw along the way. We saw that arrange, act, assert pattern that allowed us to be able to kind of test drive our tests in really elegant ways. Remember how we set up the endpoint and then we set up the conditions that made that happen, and then we filled in the setup? We kind of test drove our tests, which is cool. We want to make sure that our tests are simpler than our implementation, that we're not just duplicating our implementation in our tests. We want to run the fastest tests first, the unit tests, and then start scaling up to those tests that are slower. We want to be able to fail fast. And we intentionally closed our database connection to ensure that it wasn't going to keep going and end up killing things. We want to stop the database connection at the end of our test, and that way our test won't time out or fail. And the goal is a 10-minute build. Any longer than 10 minutes and the developer has probably moved on. But if we can get our tests in 10 minutes or less, then that's enough time to jump up, grab a coffee or a tea, and get back into it. If our tests take 2 or 3 hours, developers moved on to a different task. And so, trying to get them back in this test, we may as well just start over. Risk mitigation. Sometimes we don't want to write tests, especially if we're exploring the space or we're doing a quick prototype. And in that case, it might be more important to deploy quickly. But if our system is going to live for a long time, we want to be able to test it and validate that it will work as expected. And hopefully you've seen how easy it is to get started with unit testing in all of the places that we need to do. We did unit tests, we did integration tests, we mocked, we did end-to-end tests, and all of this in one spot. Testing is definitely within your wheelhouse, and you can do it. Testing, go do it. This has been a lot of fun to be able to show you scaling the testing pyramid in TypeScript. Thanks for coming.